Good afternoon. I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering, here to talk about RISC-V. Clearly, DAC is emptying out because every time I do a RISC-V panel, it's packed. But this will be transcribed. We'll run the whole thing. It'll be all the way through Semiconductor Engineering. I'd like to introduce our panelists. Rishir Nikhil, otherwise known as Nikhil, from BlueSpec. Megan Wachs from Sci-Fi, Jerry Adazone from CODASIP, and Ben Levine from Rambus. So all these guys play in the RISC-V world to some extent. The question I have is, how do you, as a RISC-V supplier or participant in this ecosystem, expect to make money in this field? And no order.
Yeah, so we do systems around RISC-V cores that help you bring your core to market. So there are lots of open source cores out there, and they get all the attention. It's the sort of sexy center of attention of everybody, but between getting a core and actually fitting it out into a system, comparing potential multiple different cores as to which one might be the best one for you, measuring them in some scientific way, all of that requires certain kinds of infrastructure around it. And our company focuses on that kind of work, that is building products that will help you evaluate RISC cores, have a platform on which you can modify RISC cores and have a complete system running around it, et cetera. It's not on the core itself, it's on the things around it.
So the picks and shovels.
Sorry?
The picks and shovels for the miners.
Picks and shovels and the jeans.
Okay.
Hi, so at Sci-Fi, we're really enabling extreme customization and faster time to market. And that's one thing that RISC-V enables because it's an extremely customizable ISA, and we can build an extremely customizable SoC around that. I think one thing that's really cool about RISC-V is it's sort of, you make your decision. I'm going to use RISC-V, and then I'm going to move on to the cool thing that I actually want to do. And that's what Sci-Fi is really enabling people to do, leveraging the power of RISC-V.
Hi, I'm Jerry Artizone with CODASIP, and we're a pure-play processor IP company. And to make money in this business, we can't do it on our own. We need RISC-V to be successful. It needs to be widely adopted, and we need to have a large development of a third-party ecosystem, and it needs to be robust, and it needs to be someday as big as ARMS, quite honestly. So semiconductor IP, the single largest market segment for IP is processor IP. So we're in that business, and our job is to go out and get some market share, and we're not going to do that unless RISC-V is successful. If it is, then every man for himself, we're going to have to compete against some very strong competitors, like the one to my right here. And there's plenty of market out there, so we just need to provide great products that differentiate and provide value to our customers.
Ben Levine, Rambus. So we actually are involved in the Sci-Fi ecosystem in a couple of different ways. One is we produce security IP, and that's our bread and butter business, is selling security IP, programmable roots of trust to companies making chips. And our latest generation uses a RISC-V processor that we developed specifically for security. And RISC-V was really a game changer for us because it let us control the architecture and microarchitecture and do things that enhance the security in ways that we couldn't if we were using third-party processor IP. The other way we're involved in RISC-V is there are security solutions out there that are tied to specific processors. And what we produced is security IP that can work with any processor, including Sci-Fi CPUs and RISC-V CPUs. And we've only done integrations with Sci-Fi and working with others to provide a security solution that fits nicely into the whole RISC-V ecosystem.
So Megan and Jerry, I'm curious, where do you see the biggest competition? Is it ARM? Is it MIPS? Is it the ecosystem itself?
I think the biggest competition is actually people wanting to do it themselves, because they read the RISC-V spec, they say this is awesome, this is fun, I'm going to do it myself. And then, they get about 2/3 of the way through, and start realizing like, oh, this is a little bit complicated. And so I think the biggest competition is actually internal teams. I don't know.
From my point of view, Ed, I think the biggest competition for us is clearly ARM. They own 80% of the market. So if we want to be successful, like your previous question, and become profitable and grow, we need to take some of that market share, and that's our mission. That's what we're trying to do. But again, we have some very strong competitors out there, and as they grow, they will become our main competition.
If I can jump in to Megan's point about internal teams, we did develop our own RISC-V CPU, and it was not easy, and we only did it because we had a very compelling reason to do so, because we had security features that we needed to add at the microarchitecture level. If not for that, we would be better off just buying IP from someone else who specializes in that and already has the IP developed. So I think there is competition from internal teams, but it's much more challenging than people realize when they start down that road.
Yeah, I think in the short term, it's probably ARM. And by short term, I mean, let's say next 5 years or something like that. I think in a classic disruptive scenario, what's happening here right now is that you eat from the bottom, basically. And so you go for the embedded, the small device controllers, those kinds of things, where ARM is dominant, and that's where the initial competition will come. But in time, I think there are companies like the Vector guys, the Esperanto, for example, who are doing very high-end processors, etc. I think Intel, Power are also in the sights, but it'll take longer time before that happens.
Is there a risk that, and pardon the pun here, but is there a risk that the entire ecosystem becomes fragmented because there are too many players here? Is there any consistency across the board?
So in my opinion, I'm not too worried about that because of a couple of reasons. One is that the ISA is at least so far has been fairly tightly controlled and managed well by the RISC-V Foundation. So yes, there are a lot of players, but the definition of what is a RISC-V processor comes from the foundation, and there are rigorous tests that are coming in place by which you have to convince the foundation that what you built is actually a RISC-V before you can legally even call it a RISC-V processor. So from that point of view, I'm not too worried about fragmentation on this front.
Yeah, I would also say I'm not too worried about it because it is so hard to build software, and the only way we're going to be successful, as Jerry said, is by working together. And so by kind of going off in your own direction, you're just immediately behind everyone else who decided to work together, and that's really what we've seen from my perspective.
So I'll be the third yes vote that we're not too worried about it. I'm also not too worried about it. The RISC-V Foundation carefully watches what's going on here. You have the base integer instructions that's carefully locked down. You got the standard extension space, which is monitored closely, and there's a very good ratification process to that, and then there's the customizable space. So it's up to all of us to make sure it doesn't get too fragmented and out of control, because if it does, it won't succeed. So as a supplier, as a third-party member, and as a user, it's all in our best interest to make sure this doesn't get fragmented.
And just to make it unanimous, I'm not really worried about fragmentation either, because going off in your own direction means you're really giving up all the advantages of using RISC-V in the first place. So someone who goes down their own path is really going to quickly be stuck and losing out on the benefits. So I don't think there's really much incentive to do that.
And that's been one of the...
Can I add a technical point to that, which is that I think one thing that's very unique about the RISC-V ISA design, that it's been designed with this kind of issue in mind. So it's extremely modular, and it's been designed with reserved opcode space, reserved mechanisms for extending to larger instruction lengths, etc., so that people who do extensions are not sort of randomly gluing on stuff, but they're doing it in a certain structure, they're fitting it in a certain structured way. So that's another technical point I think that is in favor of RISC-V with regarding to fragmentation.
This is something of a sharp difference from, I look back a year ago at the RISC-V foundation. And one of the concerns among the users was that the tools are not there, the compilers are not consistent, the security is missing. By hanging together, you're saying that this is all going to be solved.
Yeah, I think the fragmentation question is primarily going to be about whether when you run the same program, do you do the same thing? And that's the point on which I think there was the general agreement. I think the software stuff will follow naturally. I don't think the fact that there's a uniform hardware base will naturally bring together all these software efforts to be consistent with that.
Yeah, I mean, at Sci-Fi, we've made it a top priority to partner with industry providers, and I've seen a lot of different companies learning about RISC-V and then supporting it. You know, we have partnered with Steger and Lauterbach, debugger tool companies, and you can see all the like RISC-V Foundation member signs around the show floor today. I mean, it's just a huge community, and all the software tool developers are seeing that RISC-V is in their interest to support.
Absolutely. If we don't have great tools, Ed, this isn't going to be successful. So we're thinking about tools all the time. It's not just the hardware. It's not just the implementation. It's a lot about the C compiler, for example. We have invested in that. We've hired a lot of people that focus on building what we hope to be the best C compiler in the world for RISC-V, but we can't count on it alone. Again, the entire industry needs to have different options available for different customers. LLVM, for example, some people want to use that, or GNU compiler. So it's whatever you like, whatever your strategy is internally, and we need to support them all, and they need to be first-class tools. There's a lot of momentum right now. I see that out there. I was just at the RISC-V Roadshow in China a couple of weeks ago. We had good turnout, and a lot of third-party vendors came and supported that, and a lot of interest and a lot of questions about software performance and the robustness of tools. I think we've made a huge amount of progress as an industry in the last 2 years.
Yeah, I think we're seeing a real virtuous cycle in RISC-V. As there's more adoption of the ISA, there's more interest in producing tools, and tools are getting better. As tools get better and the ecosystem expands, there's more interest, and that loop just continues. And I think, as you said, there's a lot of momentum, and I think that will continue to grow.
Yeah, I think fortunately it hasn't happened so far, but if a big state-run player like China takes it on as official policy and they decide to go in a different direction, that's one way things could fragment, but it hasn't happened so far.
Yeah, Huawei's here, by the way. They're right over there. Do you think there's room for more than one or two major RISC-V suppliers?
Sure, I'll start this one, Megan. Thanks very much. I think it's very healthy right now having a lot of competitors out there. There's quite a few. I see 2 or 3 pretty strong ones, and we'd like to think we're one of those. I don't think, Ed, there's room for 5 or 10, but there's room for a couple, and may the best man win. We're certainly doing as much as we can. There's a lot of strong competitors out there, but I don't think the market will support more than 2 or 3, certainly. It's just my view.
Yeah, I mean, at Sci-Fi, like I said at the beginning, really what we want to do is leverage RISC-V and enable people to do really exciting custom SoCs around RISC-V. And we're also very interested in, like you said, growing the ecosystem. So we really want this to be a strong, lots of competitive cores out there so that everyone knows RISC-V is it's just the choice at this point, I think. Why not use RISC-V? And so I think it's not just about supplying the core. It's like, what are you going to do with this core that makes it interesting to your customer? And that's really where we're looking from Sci-Fi's perspective.
Yeah, I think right now it's really a good thing for the RISC-V ecosystem to see a lot of companies out there. The competition is good. It's sort of part of the natural life cycle of an ecosystem like this. initially. There's lots of companies competing. They have their own innovations and they bring their own technology to bear. I think down the road, inevitably, there'll be some consolidation and some companies will drop out and we'll end up with a small handful or less of companies that are really solid in the market. But right now, I think we're in a great place with the competition we have.
Yeah, I think another factor that plays into this is not commercial. It's national security questions, right? So countries like China and India, for example, are hell-bent on doing something local that they control, that they know what's in it, they can trust what's in it, etc. So even if it's not economically viable, I'm sure there will be suppliers for that reason. Now, they may not be as large as the biggest suppliers, whoever it turns out to be in the commercial space worldwide, but there will be many suppliers for that reason as well.
Well, this is a problem, if you're talking about security, it's not a problem just for RISC-V. People are looking at, is there IP in the chip that is not there, supposed to be there? Was it built in? Are there extra chips in the supply chain? Is this counterfeit or not? Is anything different with RISC-V than the other ones?
No, I think you have a greater scope of what you can control, I think, with RISC-V. So that compared to, for somebody in India or China, for example, which are the two people who are certainly pushing in this direction, their fear is that in the chips that they import, they don't know what's in it, right? So this will it doesn't completely eliminate the problem. And I don't mean security in the sense of the deeper sense of security like Rambus works. I mean just simply trusting what's in the chip and knowing who designed it and what's in there. Backdoors, things like that, those kinds of issues.
Yeah, the question of supply chain integrity for building chips and security assurances around IP is a really complex question. And it really comes down to being able to trace the provenance of that IP, where it came from, what happened to it as it went from the IP producer to the chip integrator, to the fab, to the ultimate silicon. And lots of people are working very diligently to solve that problem. I'm not sure RISC-V really adds much to the overall security or to the solution to that problem. I think it's one that's pretty generic to IP in general, and solving those supply chain issues is something that needs to be done, but it will involve tools and mechanisms outside of the IP itself.
Is open source any more reliable than something from one vendor? Does the full community now say, okay, we can alert you to this, or is it more of a risk?
So, there is the idea that anything that's open source and it's examined by a large community, there's a greater chance that if there's some sort of backdoor or other concern with that, someone will discover it and make that known. The problem is it still doesn't solve the larger supply chain issues. And you have, open source RTL that's downloaded from GitHub somewhere that you're going to integrate in your chip, but what happens throughout the whole design cycle of that chip from that point to the ultimate silicon? And can you really trust that the open source community is going to do as thorough a job as you would like vetting that IP? And I would argue that if you're just looking at the security of the IP itself, you might be better off having security specialists being the ones who look at it and really do the thorough security evaluation.
Yeah, I agree with that. From a sales guy perspective and talking to a lot of customers, every single customer asks about it. And it's very, very important that we have a very strong third-party ecosystem around security and working with people that know it better than anyone else. While we will have our own strategy for security, and the foundation, the RISC-V Foundation, worries a lot about security as well, to come up with at least some standard minimum requirement for that. I think we depend heavily on the people that have high expertise in this area to provide external solutions or integratable internal solutions, whatever it may be. It's very important.
So I think that in terms of things like supply chain and all, I don't think RISC-V is in any different position than any commercial vendor, other than, like I said, for certain state actors, the sense of control over the process might be good. But separately from that, the technical questions of security, the kinds of things that Rambus, for example, does, et cetera, the fact that RISC-V is open source and there's lots of open source course available has already led to an explosion in research in universities on hardware-assisted security, right? So how do you modify any ISA to improve security to a much more fine-grained and policy-based mechanism, formally provable correctness security? These kinds of things were not possible before because of the lack of access to a industrial strength ISA as a baseline on which to do that research. And now suddenly you see projects all over the place happening on that. Now, none of them have yet shown great results or something, but it's early days yet on that.
Yeah, I mean, so Sci-Fi was created by the founders of RISC-V, and they initially created RISC-V for their research lab at Berkeley, and kind of it became this very successful success story because it was so generally useful. But I think, you know, it's Sci-Fi embracing open source hardware and software is a big part of our culture and our business. But we also know that, you know, open source is not a panacea. It's not like, oh, it's open source, so it solves all these problems. We view open source as a way to get more people into the community, get you know, educational institutions working all on the same platform, like Nikhil said, and that's where we see the power of open source. It's just enabling more and more people to be working in the RISC-V space.
Where do you see, and how does it get there, RISC-V becoming mainstream? Will it be in specific markets? Will it ever get there, or be I mean, at this point, I think of RISC-V as an interesting technology that's gotten a lot of buzz, but if you think about displacing some of the major processor architectures that are out there, it hasn't done that yet. How do you see it evolving? Where do you see it playing? Is it going to be the edge? Is it going to be the server? Where's it going to play?
I'll go first. So we see a lot of horizontal applications for RISC-V. We see many different requests coming in for SSD. We see a lot of activity in AI right now, and largely because people want to lay down a lot of processors and maybe do a little customization to the processor itself and repeat that many times. So there's quite a bit of interest. But I think ultimately over time, Ed, you're going to see this in all markets. Now, that's not going to happen immediately, but over the next few years, as the companies that provide processor IP and the third-party ecosystem around it grow and get bigger and develop more IP, I think you will see us move into a broad number of market spaces.
Does the edge help there? Because at this point, there is no defined ISA that owns the edge. As a matter of fact, there's no definition of the edge that I've actually seen, but it's this vast area somewhere between the cloud and the endpoint.
Yeah, I mean, maybe I didn't quite hear your question, but so the ISA was, as Nikhil said, was designed to be very modular and very scalable. So you can use kind of the same ISA for your edge compute and all the way in the cloud, like on the server, and you just kind of tweak the parameters that you've chosen for those different implementations. But it is possible for RISC-V to come, like you said, tackle all markets kind of by the way it was designed.
I mean, I think if you use a particular definition of mainstream, you can make an argument that RISC-V is already mainstream. If you're going to say that someone who's designing a chip is going to consider RISC-V as a possible choice for an ISA for their CPUs, as compared to the more established ones, if you say that that's a real choice that people may make and are making, then under that definition, I would say the RISC-V is mainstream. It doesn't have the market share, obviously, of some of the big players, but it's positioned in a place where now it can grow and take over more and more market share.
Yeah, I think it starts, as I had mentioned in an earlier question, it starts in places where the cost of replacement is not that high in terms of compatibility and so on. Embedded systems, small IoT systems. These are things where people can switch on a dime if the costs make sense. And for them, for this kind of thing, RISC-V will make sense for them. I think that's where it'll start. But it grows from there. And eventually it'll catch up to the kinds of mainstream places in terms of mobile devices, servers, those kinds of things. Yeah.
Mic up. Based on your experience with the customer base that is looking at RISC-V, what are the most common concerns that you hear from them? Obviously, it's doing well out there, but what for everybody to jump in, what have you heard over time, and how have those concerns changed?
Well, I visit a lot of customers, so I'll take a crack at that. I'd say the number one concern is third-party ecosystem support, and that's really related to continuous integration, right? If customers are making a switch from their current processor provider, or even if they're not switching from anyone, they want to make sure that there's robust tools out there available. They want to make sure the compiler performance is good, the software performance is good, debug is very, very important. They also want to make sure that what they're buying from a merchant IP provider, such as myself, is silicon proven, it's seen production, it's seen unit volume production, and it's gone through the verification process, and it's not just some core you get off of GitHub and you hope that it works, right? You can't risk a $50 million design on an open source core that hasn't been put through verification. So all of these things matter, but really, I've heard it over and over again, it's this thing called continuous integration. Make sure the software team is very comfortable. They can drop the processor in there, they can do software debugging, they can do all the analytics they need to do, and get their schedules hit on time.
We've seen some reluctance around RISC-V for sort of unclear reasons related to it being something new. We're not selling RISC-V IP directly, we're selling IP that uses RISC-V CPUs, but we've talked to some potential customers for our security IP that are producing chips used in things like industrial IoT and process control and other things that have really critical concerns about reliability and safety. And they're just like, you know what, we've used ARM for so many years, we just don't want to take a chance with something new because they're so conservative about everything that they do. And I think that's something that will just take some time for these more conservative industries to look at the track record of RISC-V and the number of chips out there, and then they'll say, well, okay, maybe now we can trust it. But fortunately, there are other industries and other verticals that aren't so conservative or willing to work with RISC-V. And again, it goes back to that virtuous cycle. As there are more and more, as there's more and more silicon out there with RISC-V, more and more people will be willing to adopt it, which means more silicon and so forth.
Yeah, I mean, our customers, what I've seen is they're really concerned about time to market. They want to get something quick, and it's exactly what they need, and they want to be able to immediately start working with it. And I think the third-party software and the open source software community is really what they're looking at to make their decision and make sure that RISC-V is the fastest path for them.
I see two kinds of concerns. One concern with respect to the cores themselves is verification. I think if you look at the ecosystems around ARM, MIPS, x86, et cetera, the verification infrastructure that those vendors have is orders of magnitude larger than what's available now for RISC-V in terms of test suites, all kinds of things like that. So just getting it'll take time before this happens for RISC-V. So just getting the cores verified to the same level of confidence will take a little time. The second issue, I think, is about system integration, which is, we're still very immature with respect to training, documentation, standards, et cetera, on how you expand out that RISC-V into a platform, into a system on a chip, interconnects and things like that.
The closest thing I can think of to the RISC-V comes out of software, which is Linux, which is open. I think when Red Hat initially jumped into the field, they were asked, and I was at this conference, how are they going to make money out of this, and how are they going to differentiate? And basically, they provided a lot of tools and support along the way that actually made that very useful, and Red Hat has been an amazing success. So there's certainly a possibility for that working. What's happened in Linux, though, has to happen in the RISC-V world, which is that people have to be actively involved in the community. They have to be actively involved in the consortium and drive stuff back in as well as use what's there and influence what's going on. Is that happening?
Absolutely, it's happening. What a great example, Ed. The Linux example is the best example I can think of. And Linux was successful, and we will be successful as well using that same analogy. In terms of, is that happening? Is customers making, are they affecting change? I would say yes. I mean, we have a very long engagement with a very strategic large customer right now who's done a tremendous amount of evaluation on RISC-V, not just ourselves, but RISC-V in general. And they've noted some areas they'd like to see changes in RISC-V. So they've actually, through us and directly, have gone to the RISC-V Foundation and said, hey, I have some concerns about the ISA in this particular area for my particular application. And we think we have a very valid point and a lot of data here, and we think you should look at it. And sure enough, they are looking at it. So my guess is other large customers, chip companies, system companies, are making those same kind of inputs back into the foundation, and they're being heard of. And don't forget that a large number of participants and even founding members of the foundations are some of these very large systems companies, not just chip companies, but systems companies that care a lot about where this goes and being successful and being the right technology.
Yeah, I mean, the foundation is really a group effort. There's lots of task groups that are focusing on different areas. I've had the pleasure of working with Nikhil on these, and it's really an amazing experience of bringing together top academics and top industry professionals and like really tackling the various problems in a collaborative way and really, you know, not just sort of haphazardly, well, this is the spec. It's really carefully analyzed and taking feedback in from industry and the top research. I think the memory model discussion and conclusion was a great example of that, like really using the latest research to make sure we got this right. And I think that's really an amazing part of RISC-V is that you get the top talent from all these companies and industry together.
Back to your original point, Ed, I mean, I think, using the Linux example, it's like we have multiple Red Hats. We have many companies that are commercial, but they're not only using what's out there for RISC-V, they're also helping guide it, they're contributing back, and they're creating a more robust ecosystem, pursuing their own economic goals, but also leading on to the success of the whole ecosystem.
Yeah, I think both especially in the case of Sci-Fi and in BlueSpec, there's very much of a Red Hat-ish flavor to what we're doing, which is a lot of the artifacts that we use in the systems we sell are in fact open source, produced by us and put out even in open source form. But what the customers are coming for is the commercial entity that they can rely on as a partner to get the job done. Right? It's not. You're not monetizing the particular artifacts themselves, but the talent and the skill and the process of being able to help somebody build a product out of what they're doing. Yeah, I think it should also be clear to everybody also that we're still in many ways early days with RISC-V ISA, in the sense that the base ISA and the privileged architecture, these are the two parts that have been ratified, but there are, as Megan just said, there are many groups who are addressing concerns that people have already articulated, bit manipulation, vector manipulation, etc. So I think over time it'll fill out better, and there's lots and lots of volunteer work going on. I think if anything, a lot of people are frustrated at the speed at which that happens. It is all volunteer work. And so it doesn't bubble up to the top priority of the participants. So it takes a little longer than perhaps for that reason, but it'll happen.
I'd like to open this up to questions from the audience. I believe there's a mic over there. Please come on up and use it, and don't be shy. I know this is day 3 of DAC, so people are probably sitting here going, this is great, I can sit down.
Wow, it's open mic.
Hey, Mac.
Hey. So, Microsoft now has Linux inside, and do you see the same thing happening where major microprocessors will have a RISC-V core in there for some function that somebody does better with RISC-V than anyone else?
Oh yeah, I mean we're already seeing that happen. I mean both NVIDIA and Western Digital have announced strong investment in putting RISC-V processors in their designs just for that reason. Like even if there's sort of a bigger their specialized workhorse processor for these like other tasks where you have to pick something, then the obvious default choice is RISC-V. So I think there's already things going that way even today.
I'm sorry, I couldn't hear the question. What was the question?
I think he asked, would we see RISC-V inside major processor companies' designs?
Adopting RISC-V.
Yeah, I mean, just like Microsoft includes Linux now, just because it's more efficient way to do. I mean, if the keynote on Monday had security Azure being delivered with Linux in the whole Microsoft stack because of various unique features, and like you're alluding to, you're going to see something that this functionality works, and it's using a RISC-V core and then some software, but that kind of doesn't matter how it's implemented. We want the functionality, and so then maybe that just becomes part of the SoC, as just a natural part, and so that's alluding to your Red Hat model, has just pulled these things in to be just essential pieces.
Yeah, we are seeing lots of inputs from chip companies, large chip companies, and systems companies that do their own chip design in some form or fashion to include a RISC-V in lots of different application areas. In fact, I just got an inquiry before I got to this particular panel that was fairly exciting we're looking at. So yeah, there's a tremendous amount of activity around this right now for uses in many different areas. I agree.
And we definitely see for security, there's a lot of interest in including a RISC-V CPU that's been targeted specifically for security applications. So you have lots of different types of workload in a big SoC, and there's a lot to be said for specializing workloads for specific processors that are targeted for security or whatever particular application you're concerned about.
Questions?
You have talked a lot about security. What's about safety? Does exist some work in that direction to have some kind of safety mechanisms included into the RISC-V core, to have an ASIL compliant core, for example, according to ISO 26262? Does it exist something in that direction?
Yeah, so Rambus is actually has an ASIL D version of our security IP. And again, because we have
safety.
the flex.
Not
Sorry?
security, safety.
I couldn't quite hear that.
No, I would like to know about safety aspects, not security aspects.
Yeah, no, so functional safety, so the ISO 26262 spec, the Rambus IP has ASIL D, it's ASIL D ready, so that's the highest level of functional safety for automotive applications. And we're able to reach that, again, because we can control the microarchitecture. We're not tied to a specific CPU implementation. We can do what we need to reach high levels not only of security, but also of functional safety. And the ISA, the flexibility is what enables us to do that. Good question, thanks.
Well, I think that, we can't say everything about every processor core out there because there could be many, many RISC-V vendors working in this space. So I can't comment on whether they exist or not.
Time for one more question. All right, I get the feeling everybody's ready to bag it for the day. So thank you all for attending. Thank our panel.